Good morning, everyone. I'm Brad Roberts, the Director of the Center for Global Security Research at Lawrence Livermore National Laboratory, and it's my pleasure to welcome you this morning to a session with Corey Hinderstein, focused on the Iran nuclear deal, past, present, and future. The topic needs no introduction, so let me say a few words of introduction about our speaker, and then I'll turn it over to her for some introductory remarks, and then we'll have plenty of time for Q&A. When we come to the Q&A, please, those of you who would like to join the conversation, please raise your hand electronically. If you'd rather send me your question or comment in the chat function, I'll keep an eye there and ensure that time permitting, we get everyone into the conversation. But it's a pleasure to welcome Corey Hinderstein back to Livermore. She was last with us approximately 4 years ago when she was on leave from her current employer, the Nuclear Threat Initiative, and was in a role in the National Nuclear Security Administration. I should say that currently she serves as Vice President of the Nuclear Threat Initiative for international fuel cycle strategies. And let me say a word about NTI. NTI is a bipartisan Washington, D.C. based think tank focused on the development of strategies to reduce the dangers posed by nuclear weapons and other weapons of mass destruction. But it's also a do tank in the sense that it designs and implements innovative projects that can help to show governments the way forward on these issues. And it's also an advocacy organization seeking to raise public awareness and to build political momentum for threat reduction on a global scale. And many in the lab community will, of course, remember former Secretary of Energy Ernie Moniz, who, after leaving his role as secretary, assumed the role of CEO of NTI. Corey last visited the lab at a time when she was on a 3-year leave of absence from NTI and was serving at NNSA as Senior Coordinator for Nuclear Security and Nonproliferation Policy. And in that capacity, she led the department's Iran task force, giving her a direct role in the negotiation and implementation of the plan of action. She also led DOE's preparations for the 2016 Nuclear Security Summit, including a major international tabletop exercise conducted at Livermore. From 2006 to 2015, she served as Vice President at NTI for international programs. And in this capacity, she had leading roles in the creation of the World Institute for Nuclear Security, which is an international organization based in Vienna, Austria, dedicated to the sharing of best practices for nuclear security. She also played a leading role in the creation of the low-enriched uranium bank at the IAEA and in NTI projects aimed at innovation for treaty verification. Corey is a past president of the Institute for Nuclear Materials Management and has advisory roles with both Idaho National Lab and Sandia National Lab. She holds a bachelor's degree from Clark University in Massachusetts. Corey, it's a pleasure to welcome you back to the lab. Thank you very much for your investment of time and energy on our behalf. Thank you for your leadership on these issues. Let me turn it over to you to make some opening remarks, and then we'll get the discussion going. Thanks so much.
Great, thank you, Brad. And I really appreciate the kind introduction and the invitation to come and address the laboratory community. I think some have heard me say that every time I visited any of our U.S. national laboratories, I never felt more patriotic or less intelligent as compared to all of the people there. So it's really an honor and a privilege to be able to talk to you today. I also should note that Brad did mention that we brought Apex Gold, the big international tabletop exercise, to Livermore. So those of you who were around in early 2016, I think you have me to blame for shutting down your main cafeteria for a week, but I guess I also get the credit for making sure that the facility got repainted and refurbished. So I'll take that in exchange for your inconvenience. I'm here today to talk about Iran, and I'm going to go ahead and share my screens. But you'll notice a slight change from the title that Brad listed, which is, I put a question mark here at Iran nuclear deal, past, present, and future question mark, because I do think the next few weeks and months are really going to be key in what happens with the Iran nuclear deal going forward. And the only other thing I wanted to add before I kind of get into the meat of this is that I do want to thank Brad for his very kind introduction, but I want to only make one clarification. And it's only a clarification because I don't want to put myself in the position of taking credit for others' accomplishments. And that is that my role with the Iran deal came only in the implementation phase. I wasn't involved in the negotiation. But as soon as the deal was concluded and all of the parties were now responsible to implement, that's where I joined to help make sure that the United States was making good on its part of the bargain, and that Iran was adhering to its commitments from my position at the Department of Energy. So we really kind of owned all of the nuclear related commitments of the deal in coordination, of course, with the State Department and the National Security Council, and then, of course, our Treasury colleagues who are responsible for the sanctions side. I want to start with a couple of points that are not related to Iran specifically, but I think it gives a good context for our conversation, which is the need in DC to translate good science into good policy. And you know, as I have on the list on this slide, it's a rare exception where a policymaker is a scientist or an engineer or a mathematician or a programmer or anybody with that technical relevant background. And, you know, we mentioned Dr. Moniz. Secretary Moniz obviously came in as a physicist. There have been others, and the Department of Energy maybe gets its, you know, more than its share of technical experts, but not all secretaries and senior policymakers are technical experts. But decision-making processes move from the more expert at the lower levels to the less expert as the process and the problem is complex. But the most complex decisions actually have to be made by those generalists. And so it's really important when we think about something like the Iran nuclear deal, or, you know, there are many other issues, that we think about how does good science turn into good policy, and how can we play our role in that and assure that ourselves that that policy is being underpinned by a strong technical foundation. We get a lot of skepticism about this. You know, a lot of the non-science agencies, you know, I say approach these policy topics cautiously. I think that's maybe being kind, as you all, especially those of you who are science and technology experts, you know, that it's intimidating and it's sometimes frightening to think about these topics if you don't understand them. And so you hear a lot of, I'm not a technical expert, or if this is a regional expert, they'll say that's for the functional bureau to handle. So in other words, when talking about Iran, the regional experts, those who are responsible for the Middle East or the Gulf specifically, will say, okay, this is for the nonproliferation people to deal with. But we have to all be working together, and we can't just leave technical issues to the experts. It just doesn't work that way. Especially because when the generalists, the non-technical experts, need an answer, they need it now. And what I think is really important is making sure that they have that expert to ask, that you have a person in your inner circle, either on hand or that you know who to call, you know how to work the system. Again, DOE, very lucky. We have more technical experts than we sometimes know what to do with, you know, with among the labs, plants, and sites that are available. But even that, you have to make sure the right people are in the right places. And I think that Frank Wong may be out there in the audience somewhere, but, you know, this is a perfect example of where somebody with some technical expertise is now, could be either serving a detail in a policymaking shop, or just knows how to be connected in, and people know who to call when they need that kind of expertise, because it's too late if you're in the middle of a crisis. And so with that in mind, I want to do a case study of the Iran nuclear deal. And I'm going to start with what the problem was we were trying to solve. Why did Iran have a nuclear program in the first place? And why were we concerned about it in the early 2000s or 2010s? They had a research reactor that was actually supplied by the United States back when before the Iranian Revolution, and that's a research reactor that operates on highly enriched uranium. Then we had the Iranian Revolution, the change in government, and a loss of confidence, and obviously with very good reason that the Iranians could be a trusted partner of the United States anymore. Again, I'm not going to get into the politics of the Iranian Revolution and the role of the United States, but you not only had this change in government, but you had an actively hostile act with the taking of the American hostages in Tehran. But Iran approached their nuclear program with some history also. Not only did they have a nuclear program that predated the revolution, that dates back to the Shah, and ambitions with regard to peaceful nuclear energy that went further back than the early 2000s, but you also had a bad experience of Iran trying to engage with the international community. And here I'm referring to Eurodif and the Bushehr reactors, two projects. The Bushehr reactors were originally not a Russian partnership as we see now, but a German one. And in addition, Iran had bought into Eurodif, an international uranium enrichment consortium the entire goal was the partners in Eurodif would be able to get that enriched uranium product to be able to fuel peaceful nuclear reactors. What we saw is the Bushehr reactor project get suspended and canceled, and we saw that Iran not only was kicked out of Eurodif, but they never even got their investment back at the time. So they lost millions, hundreds of millions of dollars and progress and prospects. And so when they were looking at a nuclear program in the late 1990s and early 2000s, you could have some empathy for the idea that they didn't see this as something that they could do in any sort of international collaborative environment, and offers to do things collaboratively might have been met with some skepticism. And instead, they really saw the need to domesticate their capability and to be able to be as independent as possible. And here we come to A.Q. Khan, somebody who you may have heard of quite a while, a Pakistani scientist and uranium enrichment specialist who exposed as having spread uranium enrichment technology around the world. And one of the places that he shared his technology and capability was with Iran. So the roots of Iran's uranium enrichment program came from A.Q. Khan and came from those Pakistani designs. But again, this was not about having a partnership with Pakistan. This was really a vendor, a sales commercial relationship, because what they wanted to do was domesticate their program. And they started pretty early turning those Pakistani imported capabilities into kind of the Iranian versions of them. During the Bush 43 period here in the United States, there were a lot of concerns and exposures of what Iran was doing secretly, where they were violating their international verification obligations under the Nuclear Nonproliferation Treaty, because again, and I want to be very clear, Iran has been and was at the time a member of the NPT as a non-nuclear weapon state. And as part of that, they had a commitment not to develop nuclear weapons, but they also had a commitment to have the verification, the International Atomic Energy Agency safeguard system in place. In 2002, 2003, 2004, there were a series of revelations about Iran's program where they were actually not just seeking capability, but they had developed and were operating uranium enrichment without those required international safeguards. In addition, Europe stepped in at that point and tried to broker some sort of solution. There were freezes of the uranium enrichment program, and then the failure of whatever the kind of soft consensus was around that, and they would restart their activities. And there was increasing sanctions from the United Nations and the United States. When Obama came in 2008, it was following on the heels of the 2007 National Intelligence Estimate. This is the unclassified version, of course. And the unclassified NIE in 2007 said that Iran had a structured, deliberate nuclear weapons program that lasted up until approximately 2003 and then was ended. So it was exposed that they had a nuclear weapons program that has absolutely been, is available unclassified. But it's also clear that that deliberate nuclear weapons program was ended, and that they shifted to a strategy that was much more focused on developing capabilities and channeling things into their civilian program. Now, again, I would never argue that they wouldn't have looked at that and say, okay, but at least we have this in pocket if we ever decide to reverse that decision on the nuclear weapons program. But again, the program itself ended. So President Obama was interested in negotiating with the Iranians, but they just didn't have a good partner. This was Ahmadinejad's regime in Iran. And that government never seriously engaged, although there were some back channel approaches that were, and that had been ignored during the Bush administration. And so some questions may be appropriately raised as to whether they trusted that the United States could be a negotiating partner for them. But then there were even more revelations, even tougher sanctions, this international pressure. And by 2013, it was clear that time was not on our side. And I very deliberately say our, because I think it was clear for Iran that time was not on their side. It was clear for the United States that time was not on our side, and the European partners in particular. And so there was some ability to move forward at that point. And we saw by 2013 a serious, although at that point, secret negotiation to actually resolve the nuclear program. So I think this is a really important history as to how we got to where we were when we actually concluded the Joint Comprehensive Plan of Action with Iran. Before we could get to the Joint Comprehensive Plan of Action, we had a Joint Plan of Action. And this was a little bit of a, feeling out each other's positions, making sure that there was some very minimal basis of trust to move forward on. I'll come to the JCPOA in a minute and say I don't believe the JCPOA is based on trust, because I don't think any of the parties trusted any of the other parties yet. But this was the kind of the seeds here. And what the JPOA did was it created a space for negotiations where nobody rushed blindly into this process. It froze some activities, rolled back some activities. It did strengthen the verification and monitoring. It provided some sanctions and trade relief, but it had hard timelines. And I think that why it mattered is that it really proved that that this P5+1 or the EU E3+3, you can get to 6 in a number of different ways, but the parties involved, which were the US, UK, France, Germany, Russia, and China, and then Iran, could work, that this format could work, that we could reach agreement. And frankly, that wasn't just a question for the US and Iran. This was, could we get to the same place with Russia and China? Could we get to agreement with France? There have been a number of very public articles written about how the tough line that France was taking during the negotiation, beyond even what the United States was necessarily comfortable with. So it really had to work for everybody. But this coalition did come together. The JPOA time period provided this short track record, but a track record nonetheless of showing compliance on both sides, and it gave the negotiations some breathing room. And so then we got to the Joint Comprehensive Plan of Action. I think it's really important to note that the JCPOA is really, it has a foundation, and one can argue whether this is the right foundation, but really has a foundation on this concept of breakout time. And you would have heard this if you're paying attention to news about Iran, even now, how long is their breakout time? The breakout time is very specific. It has a definition. It's not a, kind of general guess about something. It is defined as the amount of time it would take Iran to produce enough nuclear material for its first nuclear weapons worth of material. And that breakout timeline is based only on the nuclear material production. So it doesn't take into account designing or manufacturing or assembling any components for a nuclear weapon or delivering a weapon. It really focused on the material. And a policy decision was made early on with the JCPOA that it would be based on preserving 1 year of that breakout timeline for at least 10 years. That was a policy decision. That wasn't, there's no technical justification for that necessarily. There are technical elements to how we calculate that. But really it was 1 year for 10 years. And then we go from there. And what was driving that was the first weapon, but also then how quickly could the subsequent weapons be have the material be produced. So it's all well and good to push all your resources towards the first weapon's worth of material, but if that was where they would then get stuck, I would be concerned, but it wouldn't lead to kind of these dramatic and catastrophic necessarily consequences if they could only get to the one. But if you can get to one and then that second one comes quickly and then the third one comes quickly, and that's all based on how much installed capacity they have to produce material, then that starts to get very concerning very fast. I'm going to focus now on the breakout timeline, verification, and then some implementation questions. I won't obviously go over every word on this slide. I just wanted to give a sense that there are commitments that lasted forever. The idea that never seek, develop, or acquire nuclear weapons. That's actually important because even the NPT doesn't have a commitment that strong. The NPT has a withdrawal clause, a national security interest clause. The JCPOA says never, and that is different and stronger than exists in other agreements. It also means that they're bound by the most comprehensive version of international verification, international inspections. That's the additional protocol, what the IAEA implements. So the IAEA has these two levels of safeguards. All countries that are members of the NPT all have to have a comprehensive safeguards agreement, or sometimes shortened to be a CSA. Many countries, more than 100, also have what's called an additional protocol. And these are measures that were identified after the Persian Gulf War, after 1990, when it was discovered that Saddam Hussein had been able to develop nuclear capabilities beyond what he was allowed to do, and they weren't detected by these international inspections. Now, I want to note, I was talking about 1990, not the 2002 timeframe. But the AP, the additional protocol, was developed in the wake of that to say, okay, it's clear we need to strengthen our safeguard system. They also agreed forever to ship out all of their spent fuel from their research reactor, and also all of the spent fuel from their commercial reactors, the Bushehr reactors that Russia is building, and the first units are now online. There were some commitments that were for 25 years, including the monitoring of uranium mines and mills. So in other words, moving the beginning of verification and of transparency up from enrichment. For 20 years, there was monitoring, extra monitoring beyond international obligations of their gas centrifuge production, assembly, and storage. For 15 years, and I'm going to go into this a little bit more detail, they could have no more than 300 kilograms of uranium, and the limit of that enrichment could be 3.67%. So when we're talking about enriched uranium, and many of you will know this, but just sharing for those who are not familiar, we talk normally about low enriched and high enriched. The dividing line for that is 20%. That's a technical distinction that, as the international community, we've decided on. So this isn't just saying they can only have low enriched. This is saying it has to actually be very low at 3.67. So up to about 5 is used for most designs of nuclear power reactors. There are some research reactors and others that use up to 20%, and some naval propulsion, and then above 20% is used for most naval propulsion, and then for weapons. And weapons grade is usually considered, there is, again, not a technical line, but it's usually considered around 90% and above. So to stay under 3.67 is quite significant. And before the deal, they were enriching up to that 20% line, significant amounts up in the 19.9% range. And they also were not allowed to have heavy water reactors. They would have limits on their heavy water. Heavy water is not a nuclear component. It's just kind of a substance that you need in order to operate some of the specific nuclear, the research reactor that they had. There were also limits on where enrichment R&D can take place, how many locations. It was limited to 1 location. That there would be no plutonium separation or plutonium related research and development, that they couldn't do work on uranium or plutonium metals. And the idea for having restrictions on metallurgy is because in order to make a nuclear weapon, you can't use the gas or solid form of enriched uranium. You actually need to use it in the metallic form. So just learning about that and going up that learning curve was something that they wanted to limit. And it allowed for the continuous on-site and daily presence of international inspectors in all of the relevant facilities. For 10 years, there was a limit. So at 15 years, we had a limit of how much uranium and what enrichment level it could be. For 10 years, we had a limit on how many centrifuges could actually be enriching. And not just how many, but what kind. So remember I said that they got the roots of their enrichment program from Pakistan. They took those original Pakistani centrifuges and made some modifications so that they could have their IR1, the IR standing for Iran and 1 first generation. So it's kind of the most basic and the least capable of their designs. And they were limited to only using those. So that was really significant in kind of keeping the learning curve down. So when we talk about the uranium pathway, what we had is we went from 19,000 centrifuges to 5,060. We went from 12,000 kilograms of uranium down to 300. This is where we were up until kind of mid 2018. And when you think about that breakout timeline I told you, the 1 year, if you can envision this in terms of dials, right? So you could have more centrifuges, but less enriched uranium stockpile. You could have more uranium stockpile, fewer centrifuges, and you can move those dials up and down until you get to a balance where the math adds up. So with a certain amount of centrifuges and a certain amount of uranium at a particular enrichment, that it would take 1 year to transform one into the first nuclear bomb's worth of material. So this is what we landed: 5,060 with 300 kilograms, 3.67% enriched uranium. We could say that gives us approximately a year. And that would all last for the first 10 years of the deal. So what you heard me say is that there were limits on both the numbers, types, locations of gas centrifuges, and the quantity and quality of the enriched uranium. And I repeat that because it's going to come back when I go to that present. I'm so far talking about the past. I'm going to get to present and future. The plutonium pathway is a little bit more simple for the terms of our conversation today. Obviously, plutonium not simple, but they had one research reactor that was still under construction. It never operated. It's called the Arak reactor. It's also called the Kondab reactor, and it was going to be producing really good plutonium once it operated. Basically, it was a design that was maximized for the production of the kind of plutonium that is easiest to use in a nuclear weapon. Then that's not why they said they were doing it. They said they were doing research and development, medical isotopes, et cetera. But that the result of this operation would have been a significant amount of plutonium coming out every year if they were to separate it. So they agreed to change the design. Again, it had never operated in the old design. So we agreed to help them redesign this, and our colleagues at Argonne National Lab took a great, a significant part of this, and our colleagues in China were really the technical leads because they've already converted a reactor that was very similar to this in Algeria to the other design. So instead of going from going from natural uranium fuel, it was going to go up to 3.67% fuel, and that would result through the operation of this reactor in producing very little plutonium byproduct, and the plutonium it produced was going to be very low quality, hard to deal with for a nuclear weapons context. You might have kind of seized on that number, 3.67. So now you see there's a reason why we landed on that as the uranium enrichment limit. It wasn't random. It wasn't pulled out of a hat. It's actually the uranium enrichment level that would be needed for this reactor. So these two things do connect. But what happened in the short term is the calandria, this metal piece that you see here on the bottom left in the picture, the core was filled with concrete, so it could never be used again. It was, once it was filled with concrete, it was corrupted. It could not be used. So even if the concrete were removed and they tried to, they would have to start over on this. And then finally, verification and monitoring. I really want to highlight this because the rest of the work on verification and monitoring, the rest of the limits are kind of, they're important, they're extremely important, but they are all backed up with verification and monitoring. And the idea of breakout time is inextricably tied to verification and monitoring. And what I mean by that is breakout can either be secret or it can be fast, but it can't be both, because breakout assumes you're going to use everything you have, in your system to go towards that push to the first bomb's worth of material. You'd have to use the existing material, facilities, equipment, people. You would have to turn it all towards a nuclear weapon purpose. Suddenly you're not enriching to 3.67, you're trying to go up to weapons grade, and you have to use the facilities and material that you have. That's why verification and monitoring is so important, because when we have inspectors on the ground every day in these facilities, they could make that decision, but it would be visible immediately. If the monitoring isn't happening, then they could be using all of these facilities and we wouldn't know. So if you assume that it's going to be obvious right away using existing facilities, it means that in order to do it in secret, they would have to duplicate all this capability. They'd have to duplicate the enrichment capacity, operations, the uranium feed, the uranium enrichment process, and they'd have to get people who know how to manufacture, install, and operate all of these capabilities. And they don't have unlimited amounts of people who know how to work gas centrifuges. So in order to duplicate it all to make it be in secret, they couldn't do it quickly. It would take time to reestablish all that capability. So that's why I say verification and monitoring matters, because it makes sure that that timeline is either going to be the fastest, but that means we see it right away and can react right away, or it's going to take them a lot longer. This is just an example of a few of the verification and monitoring innovations, and in particular, this blue one on the right, our friends at Oak Ridge National Laboratory developed that. It's called the Online Enrichment Monitor, or the OLEM, and that blue box that fits around the pipe, that's where the innovation is. So usually you know what enrichment levels are by looking at the product. So you find the end product and you sample it and you test it and you say, okay, here's what the enrichment level is. What this allows the IAEA to do is know what the enrichment level is of the gas going through that pipe at any given moment. So it's more like watching something in real time versus taking a snapshot of it at the end. And that was to allow some earlier notification if they were to start to increase the enrichment level within the system. And Iran is the only place in the world where the OLEMs are installed. So that's pretty exciting. This is just my eternal gratitude and shout out to the labs, plants, and sites that really did a lot to support the implementation of the Joint Comprehensive Plan of Action, both in assessing Iranian capability and evaluating procurements. We didn't get to the procurement channel. There's a lot of other things that are related, but I really wanted to focus on the nuclear program because that jumps us to currently. All right, so where is Iran right now? What's the reality on the ground? And I can say very specifically, the reason we know the reality on the ground is because we do still have inspections going on. So I mentioned quantities of enriched uranium, enrichment level, numbers of centrifuges, location of centrifuges, and type of centrifuges as the 5 commitments for in the enrichment program. Iran is now above the JCPOA limits on all of these. So on quantities of enriched uranium, they are, instead of being at 300 kilograms, they're at just over nearly 4,400 kilograms. Again, remember, they were at 12,000 before, so we're still way below where they were during the JCPOA, or sorry, before the JCPOA, but it's significantly above where they should be under the deal. They are now also operating more in centrifuges. They have operated more advanced centrifuges, so not just those IR1 first generation. And they're operating enrichment capability at not just the one allowed site of Natanz, but also at the Fordo site, which was one of the secret sites that they developed without notifying the IAEA originally. Again, we are on site, the IAEA, the international inspectors, are on site in all of these locations. So we are watching what's going on and we know it's happening, but we know it's happening. And Iran is declaring it. They're announcing what they're doing every step of the way. Starting just within the last couple of weeks, they also started work on uranium metallurgy. They have only produced 3.6 grams of uranium metal, but still this was supposed to be a zero capability, and they're now doing uranium metal work. The good thing is that they are not doing anything on plutonium that is different from what they're obligated to do. So they haven't violated any of their obligations on plutonium. And Iran has has just over the last weekend started withdrawing some of their support for the IAEA monitoring mission. So I remember I mentioned the CSA, the Comprehensive Safeguards Agreement, that's the base level. Then there's additional protocol, and then there are all the pieces that are added on just for this deal. So they are now only implementing the Comprehensive Safeguards Agreement. They stopped the additional protocol and some of those other measures. And what we know is that the CSA means that the IAEA is still on the ground and inspecting on a regular basis all of the places where active nuclear material activity is going on. So they are still in the uranium enrichment facilities. They are still dealing with the operating centrifuges. But where we've now lost some access is the kind of surrounding facilities. So like the centrifuge manufacturing workshop, for example, some of those things. So it does significantly reduce our insight for now. But the good thing is the IAEA Director General went to Iran this past weekend, reached a deal with Iran, a bilateral technical arrangement that would allow the data to be preserved for all of the activities for which they are not allowed to have access right now for 3 months. So the IAEA is not on site in all of those places now, but all of the data related to that activity is being preserved in the secure way. And if the parties come back, the political process can work, and Iran resolves the issue, and they come back to their verification, the IAEA is confident they will not have lost any of that continuity of knowledge of what happened during that time. But if it goes on longer than 3 months, that'll start to be a question. So I think it's really important to note, and you haven't heard me say United States once, I want to fully acknowledge that Iran took these steps in response to the United States backing out of the agreement. Starting in May of 2018, the United States slowly stepped back from some of their obligations and declared itself a non-participant in the deal going forward. And not only that, but some of Iran's some of the United States' sanctions activity actually limited the other members of the deal as well. So the United States has this policy called secondary sanctions. And what that means is, if I am going to sanction a company in Iran, then I'm not only just sanctioning that company in Iran, I will then sanction any company that does business with that company in Iran. So the reason that matters is if you were in the UK or France or Germany, for example, and you said, wait, I didn't back out of the deal, I still want to meet my obligations, but now I can't do the things that I am obligated to do. I can't conduct the business, I can't do the banking, because if my company does it, they're going to be sanctioned by the United States. And frankly, it's very, very few companies in the world that will choose the Iranian market over the United States market. The scale is just off. So if you're a bank, or you're an oil company, or you're a car company that was going to do some work in Iran, you're not going to risk the ability to do work in the United States for that. So they ended up backing out of a lot of those activities, and it put them and our allies in a very tight spot. Iran also did not ramp all of these activities up at once. We really saw them doing them step by step. They slowly, and at a period of 60 to 90 days, would keep adding a new activity. Again, as we saw just up until this last weekend. And the good thing is that with some limited exception regarding kind of knowledge, regarding learning, all of the steps that Iran has taken are technically reversible. So you can downblend the uranium to lower enrichment levels. You can remove uranium. You can uninstall centrifuges. You can consolidate. So all of these points are absolutely technically reversible with the limited exception of know-how. So I don't want to say that's nothing. It is significant, but to me, it shouldn't be a barrier to making progress. What we really see is on the types of centrifuges, meaning some of those advanced beyond first generation, and now in uranium metallurgy, the people who are learning things through that process are, they're going to have learned it. But I would still say that knowledge that is gained but then not exercised, I will take that over, the unrestricted activity that we see today. So this is Iran's current activities in the nuclear space. So the short answer, if you look right now at a snapshot, is no party to the JCPOA is fully in compliance, but fundamentally it's Iran and the United States that have stepped back, and Iran and the United States that need to come forward. So I'm going to end I was asked to speak for 45 minutes. I think I'm just running up on that deadline with where are we now and what are some of the next steps that we have to watch for? What should you be watching for as you look at the news on this? Some of you who know your memes will appreciate this, but this is where we are now. Iran says we're not going to come back to the table. They said this again this weekend. We're not going to come back to the table with the United States until they lift the sanctions that were reimposed. And the United States says, well, we're not going to lift sanctions until Iran ramps back its nuclear program again. And then you just end up a lot of people pointing at each other. Unfortunately, we can't do this forever. We're facing both technical pressure because, like I said, capability is increasing every day in Iran, but we're facing time pressure and there are domestic politics in both of these countries that we're managing. And the biggest time pressure is that we just went through our election season. It came out how it came out. Some people are happy with the Biden victory, others not. But either way, that was the result, and now we're moving forward from that. Well, Iran is in the same position. And June 17th, they have their presidential election. So when I gave you that history and I said a big change happened when Ahmadinejad left and Rouhani came in, well, Rouhani's going out. He's term limited. So not only are we trying to figure out who's going to be the next president in Iran, but the likelihood is, just looking at the kind of where the political winds are blowing in Iran and not unrelated to the nuclear, the response of the United States to the nuclear deal, it's likely to be a harder line government. And again, in Iran, even saying a more moderate government, we're talking about a scale, but this is likely to be a harder line government. And so the question is, can we make enough progress between now and June 17th that even a harder line elected government will see the value in staying in the deal or in making additional commitments? And I think these are really serious open questions. The United States has certain sanctions that it imposed since 2018 that can be easily lifted just by executive order, but others that cannot. The sanctions that were waived as part of the JCPOA that were reimposed had to do with the financial, energy, and automotive sectors of the petrochemical sector, joint ventures, and there are other, but then there are other sanctions that were put on that are not specifically called out in the JCPOA, but rather were put on individuals or companies, and they may have been lifted under the JCPOA, but they were reimposed under different justifications. So reimposed because they are connected to terrorist activity or support for terrorist actions, or other, in particular, other regional activities. And so if it was lifted because of the nuclear deal, but reimposed for a different reason, there are serious legal questions about whether they are required to be lifted again, because even under the deal, we always kept our national capability to impose sanctions related to terrorism activities. So it becomes very complicated. And I mentioned domestic politics, but domestic politics are not nothing here either. And there are a number of key members of Congress that support going back to the deal, and others who didn't like the deal in the first place and would not be excited about going back. And they definitely don't want the United States to go back based on a time pressure that Iran is putting on us. So it becomes very complicated. Now, am I optimistic or pessimistic? Anyone who knows me will know that the answer is I'm optimistic, because I'm just perpetually optimistic, but I'm also practical. And I do see that there is a diplomatic path, that gets out of this Spider-Man situation, which is one doesn't have to go first, but you do have to start talking to each other and figuring out where you can do mutual and reinforcing steps, so that nobody says that they went first, but each action happens because the other one is taking a reciprocal action. And I believe in our diplomatic process, we've been able to manage more complicated things than this, and I think we can manage it, but it really has to do with political will. Does Iran see that there's more value to them coming back to the deal than staying out of it? Does the United States see that there's more coming back than staying out? And the fact of the matter is that we won't go through another 3 years, like the past 3 years, of kind of this gray area. I don't think that China, Russia, and the other members of the deal will continue to stay in if there isn't a clear path forward, and definitely not Iran. So I think that between now and June 17th, we will know where we're landing. Either there will be a deal going forward or there won't. And if there is, we have the opportunity to engage with Iran on a number of other issues that are extremely important. And if there's not, I think we may have a broken relationship that is as bad as anything since 1979. So that's my pessimistic note, but my hope is, and my confidence is, that we won't be there. So I'm going to leave it there. I will end my share screen. I know we have time for Q&A. I'm looking forward to it. This is my email address, my Twitter handle, and you're welcome to reach out to me through either of those if you'd like to engage separate from within this session. But I thank you very much.